Okay. Maybe you want to say hello if you are there, so I know you can hear me, and let me know if you can hear me. Should be able to hear me if anybody's there. Okay, great. We can start in a second. Let's see if anybody else joins. Just posted. Okay. All right. All right. So let's do this thing. All right. So hello, Campi. And we are going to record it, so if people want to see it later, they can. But basically, we can start from here. We are working on a chart that is going to be interactive. The chart is also going to produce signals, so it's going to make predictions. It's going to have the general model. The general model, that is that yellow line in the middle, right? Because basically we are claiming, if you follow a little bit my work, but I will also try to kind of go to the basics, because that is what is this meeting is about. We want to discuss the basics for maybe the people that never heard about the power law, or maybe they need a refresher. But the main idea is that we claim that we found some kind of basically we crack. I know it sounds crazy, but we crack the Bitcoin code. The Bitcoin doesn't behave like a normal asset, but it has all these network properties that make it behave more like a natural phenomena. And with natural phenomena, I don't mean that it's like the planet exactly, but it can be described by the same math. It can be described by equations that are relatively simple, because people don't realize a lot of things in nature are simple. They behave in a simple way, and there are reasons why that happens. And this allows us to kind of predict the long-term behavior of Bitcoin. And a lot of people are kind of concerned or scared or misunderstand what prediction means. The predictions, because first of all, if you say that something is behaving like a natural system, it's going to be predictable. This is what we do all the time in science. This is why a few days ago, yesterday, when it was, we knew there was an eclipse. That is science. We predicted. We knew you could calculate hundreds of years ahead that an eclipse will happen, because we know that things happen in a certain way. They are periodic. We can calculate using the science that we develop to understand how planets move when an eclipse will happen. We know that. And that is the power of science. If you want to send a probe to Mars and land on Mars, or you want to make contact with a space station, you know how to calculate these things. You make predictions. You predict the path of a spaceship. It's science. Science makes predictions. Science is all about predictions. So if you're making this strong claim that this behavior that we observe, it's a result of some natural law or some natural behavior. Now, the natural law involves humans, of course. It's not just humans. That is other thing that people misunderstand. We are dealing with a system that also involves machines, because there are all these mining machines, and also Bitcoin itself is a code, differently from any other. This is why it behaves in such a different way from a stock, from gold. It's not comparable. Yes, we trade it, we buy and sell it, and it's supposed to be the monetary system of the world one day, but it's different because it's a code. There is no other asset that is a code that does certain things. It's programmed to do certain things, like even the schedule, right, of monetary distribution. Many coins are produced. It's a formula. It has this halving that is happening at very regular times. There is no asset base in this way. And also the difficulty adjustment that produces certain kind of pressure in how many coins are mined. The miners have an effect on the price. It's a loop. It's a loop. So, there are all these mechanisms that make it behave in a different way. And then there is the social aspect of it, where there are social interactions, because it's not obvious. Meme coins, for example, behave in a very different way. They are also like a virus, but they are more like a bad virus because they spread in a exponential fashion. People get crazy, they buy this coin, and then what they do? They crash. This is why exponentials are no good. While power laws are all about sustainability, strength, stability, all these things that are good things for something that want to be the monetary system of the world. This is why I cannot stand when people say it's just a straight line, you draw a straight line. No, we discover something so fundamental and so beautiful about Bitcoin that if you love Bitcoin, you should be aware. Look at this curve. Look how amazing this curve is. It's not something that can happen by chance. And as consequences, because the power laws are things that are happening everywhere in nature, and they have meaning. They have all kind of beautiful characteristics. One of these characteristics is that you can predict what they are going to do next, because they are called scale invariant. And what it means, scale invariance, it means that if you draw a triangle here, you see a big triangle, because it looks like a triangle, the log of the time here on the x-axis and the log of the price on the y-axis, you can make this triangle bigger, right? There are even lines here. You can see it with your eyes. What happens if I make it bigger? It will scale up, everything in proportion. And that scale invariance that I use all the time, you can also translate it as everything in proportion. It will scale up proportionally. And it's a property of a system. I know it sounds simple, like you are making the triangle bigger. How can you do that? I can't. That is what scale invariance is. In fact, do it here. The trade takes just only this small little triangle until 2012, 11, right? And make now the triangle bigger, and you see what I'm talking about. That is how this scale invariant system work. And there are one of a few times when scientists can make predictions very confidently. One is when you have scale invariant systems. I gave some time example of a growth of a tooth of an elephant. It's also a scale invariant system. You can look at an elephant growth of a tooth at 5 years and measure it, see how it changes over time, and you can project that in the future. And it will continue to do that because it's the mechanism underlying our tooth growth that keep it going in that way. This is how it works. And so this is how these things work. This is why we, when I saw on Glassnode, they show this model and they say, oh, it cannot be used for prediction. Based on what? You are trying to give information and you're giving the wrong information. I know that they are trying to be conservative because according to them, because they don't hire physicists, they are finance people that have no clue. The finance people will want to be conservative, say, oh, don't use this make a note saying, investments are risky. You should never trust a model 100% because it's still an asset, right? It's not really planets. Even with planets, we never know. We never know if the Earth will continue to go around the sun forever. We don't know because something can happen, that we didn't understand about the laws of nature, but we are pretty confident, right, that the Earth will continue to go around the Earth. So this is not like that, but close as much as you can with an asset. the fact that Glassnode says it cannot be used for prediction. It can be used for prediction. Don't talk about stuff that you don't know. You talk about a scale invariant system and say fake news when you don't know physics. This is physics. It's not finance. So if this system, if a theory is correct, that we're dealing with a scale invariant system, it will continue to do this. It will need a catastrophic event. And we had catastrophic events. For example, see, look at COVID. COVID is 2020 year like 0102, right? If you go around that date, just a little bit of a halving, in fact. That deep that you see there, that looks deep, small when you look in this log scale, but it was a huge, big deep. It was an enormous deep. Well, notice what happened. It bounced from that green line. The green line is the bottom. You can see that green line touches the bottoms. Also, that is not due by chance. It cannot be due to chance. There are very real reasons why the green line touches all these bottoms. And even during COVID, we went there, we bounced back. And this is another property of power law system, of scaling invariant system, that they self-protect. They are very resilient. This is why all these things are very beautiful when associated, deep coaching, when are associated with power laws, because with Bitcoin, because it's all positive things, all beautiful things. I don't know why people are not, they don't fall in love with this. Not with me. I don't care about me. I care about Bitcoin. I'm showing you how beautiful, amazing Bitcoin is. And it has all these amazing properties that are all the things that we always say about Bitcoin, but now we can prove them mathematically. So now, of course, take with a grain of salt everything we do that involves investment, involves money. We want to be very careful. We want to be understanding. We want to be, if you want to do something using this information, like, you want to sell at the top, buy at the bottom, do it carefully. Don't sell everything. Sell 20%, sell 10%. Don't sell at all. It depends on your style. But, for example, stop buying. Don't buy at the top. Save your money, do DCA, buy at the bottom. This is how you use this information. And some people say, oh, it's not precise. Look how precise it is. If you follow the instruction and you understand what we're talking about, look, buy when it's green, sell when it's red, or don't buy when it's red. And the cycle are very precise because Bitcoin has the two things. Remember I told you there are two cases when scientists can do prediction. One, when we have something that is periodic. This is why we do these circular charts. I would love to put that too. And at a certain point, if you have a chart that has a clock and all the power law information, and if you combine the two, now you have the two things that scientists use to make prediction. We have something that is periodic and something that is scale invariant. And Bitcoin is both. So it's the most predictable of all the possible assets that you can imagine, because it's not an asset. It's something different. We should not even call it an asset anymore. It's like, it's a city. We are living in this city. We are coming in this city. We are citizens of this city. We are Bitcoin citizen, whatever you want to call it. And we are investing in this city. We are investing in the city, and the city rewards us, because if you're a good citizen and you invest in the city, invest in the system, early your investment, you get payback. And there are all these studies that show that power laws show up in cities, how fast a city grows, the number of patents that are produced in that cities, the GDP of that cities, the number of gas stations in that city, how fast somebody walks in a city, all power laws. It's like that. It's like that. I mean, if you don't like it, Feynman used to say, hey, this is how the universe works. These are the equations of the universe. If you don't like it, go find it another universe. Go find another Bitcoin. Bitcoin is like that. It behaves in this way. Anybody that says it's not the case, look at the chart, 8 order of magnitudes. Basically, we were making a video with my son, by the way, about this. If you didn't see the videos, you're in this channel, please subscribe. go and watch all the other videos that we made. We spend a lot of time. My son is a professional in making these videos. I watch them. There is one about the power laws. There is one about the bubbles. Go and watch them, even if you don't agree in everything, because it's not. We're not trying to create a cult. This is not a cult. It's trying to share information, and learning from Bitcoin, learning from each other, and this is what we are trying to do. But we are making a video about scaling, this very important concept of scale, and hopefully you will like. But we will try to find an analogy, like something that I use all the time, because if people traded 10,000 Bitcoin for $1, right? So that is basically 10 to the minus 4. And we are almost 10 to the 5, because 100,000 is 10 to the 5. So that is almost like 9 order of magnitude. We never had any asset on Earth that ever behaved like this. We went from being something that was basically nothing. And in a moment, I will show you the model can be used to calculate when Bitcoin was, like 0. And so if you actually include the time when it was, like, I don't know, a billionth of a millionth of a dollar, it's also more of order of magnitude, but anyway, so if you include all these changes, even if you just go from the first transaction, we're talking about 8-9 order of magnitude. That is the equivalent of, let's say, a mouse. A mouse is 10 grams. Okay, what is 100,000? Sorry, if you start talking about 10 order or 8 order of magnitude, you're talking about 100 million times bigger than a mouse. Okay, that is not even an elephant. You would need to have a whale or even a dinosaur, right? So going from a mouse to a dinosaur or something like that is what Bitcoin did. And it did it in this very regular fashion, in this very precise scaling way. Do you think that to go to the next order of magnitude, that is when Bitcoin is going to be 1 million, that is going to take 10 years, is going to change? No, it's not. It's ridiculous. In fact, you're ignorant in science if you're saying it's going to change. It's not, because it shows that it is a fundamental property of a system to do this very regular change. And this is what these scale invariant systems do. So the finance people will tell you, no, it's not predictive. A scientist will tell you, yes, it's predictive. If the theory is correct, right? We never know if a theory is correct 100%. Never. Even astronomy, you never know, okay? But you never know even if the sun is going up tomorrow. So, but, we make plan for going to school and work, etc., right? So we can make plan. Just be careful, keep your eyes open, don't trust anybody, even me. Just double check, okay, everything. If you're able to produce this chart, much better. And use your discrimination and understanding. And then maybe you can use it for yourself and multiply your Bitcoin, because that is the plan. By the way, I want to invite everybody that is interested in all this to join the Discord. We have a community. We have about 300 people there. And we have classes. Like at a certain point, there was a rumor that I had a class. I didn't understand where this rumor was coming from. And finally, I got it, because I put like a self-deprecating picture of me with a clickbait. Somebody made that clickbait was from a video, but I thought, this is funny. I'm going to use it to make fun of myself and say, exact date. Astrophysicists predict exact date of when it will be 1 million. And I had a funny face, like this. I said, this is funny. I'm going to make fun of myself. And somebody took it seriously and was spreading these rumors that I have a class that teaches people when Bitcoin will be 1 million to the exact date, the second, the milliseconds. It's so stupid. I don't know why people do these kind of things. But I had to change it. I put it like a warning, it's a joke, because otherwise people will use it against me. But the classes that we have are, people coming and talking about what they think is going on, or improving the charts, or telling ourselves we should do this, we should do this other. Everybody can talk and contribute. In fact, there are everybody helping each other. There is somebody that is helping more than others, but it's amazing. It's an amazing community. So join us. I will put a link on my X. It's basically through our Patreon. And in fact, Semi-Face, do you mind to put the link? The link to Discord. You go, no, don't put the link. It's through the scale invariant. See if I can do it actually. I will put it in the chat. I think I can do the chat, right? Yes, this one. Go through the Patreon, and then there are instructions here on how to join. And we also have 2 classes 2 times a week, but we talk mostly about the indicators that we're developing. We talk about DCA, how to do DCA with these. And plus we have like a club, book club, where we talk about these. We will talk many books, beautiful books about physics and trading, or physics and the market, how physicists use physics to predict the market. Because we have been very successful funds that were based on using this idea from physics. And you can doubt math, you can doubt gravity, jump from the window and see if you can doubt gravity. Math is the language of nature, right? This is what Galileo said, or my countryman, but also the founder of science, in a sense. He said that, nature is a book and is written with the language of mathematics. It's a truth, because otherwise, even the computer we're using right now, there are sometimes people that are thank you, Tom Asher, that was so nice and generous. There are people that doubt science, etc. Yes, sometimes any human activity, you can use it for politics and bullshit and corruption, etc. Any, right? Nobody, we are still human. And look at the history of science. It's among the most generous, the most selfless people. They didn't make a lot of money. Because for one Elon Musk, you have 10,000 scientists that get paid almost nothing. We work a lot and we improve humanity. The computer you're using, it's who do you think made it? Not basketball players. It was scientists, right? Scientists, engineers. Engineers take what scientists discover and they made it practical. CAT scan, physicists invented them. Telephones, physicists. It's all the things that we do are based on science. It's our savior. We should make them heroes, like hero society. And they are humans. Sometimes they are stupid. Sometimes they get corrupted. We are all humans. But it's among the activity that are least corrupted, because there are different mechanisms to adjust when somebody goes cheating. Once in a while, there are people. I was following the studies of this person that was cheating in science. Is the worst possible thing that you can do. If you cheat in science, it's so terrible. But there are some people that do it. But then they get caught. They get caught. You know why? Because it's an open source kind of initiative. This is what is beautiful about it. Plus, it's like Bitcoin. You cannot bullshit Bitcoin. Okay, if I made something that is bullshit, somebody will find out. That is the beauty about. In fact, the beauty of using science with markets, if you are bullshitting, is you very quickly find out, because you lose all your money. You use your if you're working for somebody like Wall Street, use your clients' money, and they go after you. If you bullshit, it's very quickly they found out you're bullshitting. In fact, the market is probably one of the hardest things to try to apply science to, because it's really tough. With Bitcoin is different. Look at all these regularities. In a sense, it was actually easy for me, because it was like a low-hanging fruits to find this stuff. It's just that nobody looked at it with the eyes of a physicist. And this is why physicists are among the most successful scientists, because we are trained in a different way. We use all these very, 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 I don't know how to call it, kind of down to earth in the end. We try to look for simple things, simple explanations for nature. And it works because nature likes simple. Okay, so what I wanted to show you, because this was kind of a general introduction. Let me take any question. Then what I want to do, I want to show you this little tool that you can find free online to give you an intuition of what this power law is. It's the next thing we are going to do. Yeah, I can take these questions, but when we have this model, it will show what is the target. This is what we're doing. You see how it tells what the cycle 5, 6 is, but it's all A and N. That means not a number because we are still working on adding our projections, etc. So we will have all that. I want to focus on really getting to understand the math and understanding the power law in an intuitive way. So I can answer, basically, just to make you happy, it's the date is going to be the end of 25, around November, December, and the projected price right now. And again, it's not so important what is the price. It's more, if you look at these bands here, by the time we go close to the red one, it will be time to, take some profits. And it doesn't matter if it goes above it, because it can leave a little bit of your Bitcoin running and do DCA a little bit, very carefully, very focused, very aware of what is going on. So the real price doesn't matter. But right now, if we continue to see this, basically see how these peaks are kind of decaying, they're becoming smaller. If you say, and that is only 4 points, so we don't know if we will continue to do that, while the general direction is thousands of points, so we know that it's doing this. But if you, sometimes you use what you have, right? So we have only 4 cycles. So if you project it in the future, it's also a conservative approach. Better to be conservative at hyping people. That is the other thing we do in our team. We want to rather be conservative, and then if you do better, great. But it's better not to create a lot of expectations and then people get burnt. If I tell you, oh, it's going to 1 million, and then people buy when it's time to actually to go down, they get burned. And some people leave, because it's not that, oh, look, eventually you will still make up your money if you stick with it. Some people don't stick with it. They get really scared and they leave, and it's not good. It's not good because we have a responsibility when you do these things. If you're trying to tell people, something that others don't, you need to take responsibility. You need to be responsible for for the things you say. So we try to be as conservative as possible, optimistic, because we still believe that this thing is going up and up and up. Look at little line. We believe in Bitcoin. We are not bears. We are telling you, oh, look at this. During the bear market is going up. Then we go more up. The only time there is only 1 year. This meme, ciao, Cuisine, I don't know. Hopefully I pronounce your name correctly. So this meme of 3 green bars and 1 red, that is actually true, because you see 1 year goes up, during the bear market, then it continues to go up along. Look how amazing, right? It follows the power law. And then during the bull run, it's 1 more year, and that year is crazy, right? We go even faster. That is the only time when we go exponential, when it goes exponential. You see how it's curved instead of being during the bull run, during going up, during the bubble, it's curved, right? The price is curved. That means exponential. And then it goes down as fast as before, as it went up. And then, so basically that is the only year. So it takes 1 year to go down. That is the only year when it's going down. Otherwise, it's 3 years up, 1 year down, but down from these very high tops, and so if you understand these and you put it in, and we have also these circular charts where we tell you all the different phases of a cycle. It's a very powerful tool that you can use to do whatever you feel. Like for example, my friend Fred, Fred Krueger. I don't know if you guys follow him. He doesn't like this idea of using the cycle for whatever reason. It's he has a lot of Bitcoin, so it's his style, and it's okay. And he says, I like it because he's a fanatic of the power law. And he likes it because it gives him confidence of what is going to happen. It gives a feeling what happened in the future. But my position is different. We don't have to agree on everything. My position is that if you study and you think about it and you use it and you're careful, then you can use this cycle on your advantage. And you can, because you know what? We have these charts where we show that the all-time holder, the people that hold it for 5, 6, 7, 10 years, they do exactly that. They dumped at a peak. One of the reasons why it crashes like that is because these guys dump it. And it's not because you hate Bitcoin, because you're taking some gains. And then the same people buy back at the bottom. Why don't we do that too? If they do it, why don't we do it? Partially, if you are concerned about letting go of your Bitcoin, do it with 20%, do it with 10%. Or do DCA, like I say, do DCA, but we're going to create signals out of this that tells you, okay, save your money, don't spend everything. Don't spend everything, save your money, wait when we are, in this red area, wait until we go the bottom. The bottom, we are like really good in predicting these bottoms. We are really, really good. It's almost like a very strong barrier so that we never go down. So when we are at the bottom, we will let you know. And so sell your chair. If you have do you have an extra chair? Yeah, exactly. This will be the app. It will be a app that you can download and use. And technically, you can use a signal that you can then do by Ciao CE. You can do it manually, or you can choose, or you can make it automatic. You can put some USDT on an exchange, and then it will do it for you. We'll do the DCA for you automatically. So we are working hard on all this. So we give tools to the community. It's becoming my full-time job. Some people criticize me, you are trying to monetize. If I wanted to monetize, I would have sold myself to Wall Street, presented this to Wall Street, not even let anybody know, and I could have made 10 times more money or more. Instead, it's the contrary. This is why even when I published my first articles in Reddit, I was doing it in Reddit, getting a lot of flack there because people didn't understand it. And I did it because I love the community. I love Bitcoin. I love the Bitcoiners. I am one of you. I'm like older brother of dad, if you want, whatever you want to consider me. And I'm trying to help you, with my knowledge, sharing. And so this is what I'm doing. But at the same time, I decided to make it a full-time job. And so I'm trying to find a way to be reasonable. We will never charge you $100 for something. At the same time, if you can support us, and there is my son that is part of the team. We are bringing my Italian friends that are helping. This I didn't do this. This is actually the help of my Italian friends that are like professionals, so professional people in computing, etc. So we're creating a team. So you supporting us, we support you. That is the idea. And we will always be reasonable, because we care about the community, So anyway, let's. Yeah, it's not price projection. It's not. It's like science. It's like we're trying to. I know. Reddit mods remove my post when I mentioned power law. Yeah, they actually did the same thing with me. They started to be like very aggressive. I don't even understand. It's so completely idiotic because one day this stuff will be, if this stuff is true, it will be in the textbook. It will be in the history books. They say, oh, there was this system called Bitcoin, but no, Bitcoin, everybody will know Bitcoin in 20 years from now. It will be one of the most important discovery of mankind. And this crazy guy, Italian guy, Giovanni, discovered that it was like a natural system. It will be there in the textbook. And these guys that have a Bitcoin, Reddit, repress it, they will make fun of them. They will make fun of them. So I look at it like we make fun of the people that believe the Earth is flat, or they prosecuted Galileo, stuff like that. It's stupid. It's stupid. I don't know why they're doing this. I don't know. It's their problem. But anyway, let's. I wanted to show you. So I'm going to switch. Stop sharing. Let's see if I can share this other thing. Okay, cancel. I want to share this. So let me switch, and then let's see if I can share this window. Let's see if I find it. I will make a separate window, I think. Give me a second, okay? Let me make a separate window, see if I find it in that way. Okay, let me try again. Okay, let me share it. Window. Okay, here. All right, so it's this app, and hopefully you see. So I would like everybody, please, if you can, maybe some people are on the phone, it's a little bit more complicated, but maybe even on the phone, it's relatively simple. Go under desmos.com, desmos.com. And if it is not, then maybe you can go back when you watch this again. I will make it available on the YouTube channel. And there's a very nice app because, first of all, if you take any class in math or whatever, it's going to help you. Maybe you're aware of this app anyway. One of our Discord member, basically, I'm trying to recreate what happened yesterday because it was very nice. We had this like a 1 hour meeting, and this guy told me, "Oh, you know what? You can use Desmos." And I knew about this app because my girlfriend at some point took like a calculus class, and she's older, but she's going back to school, and she was taking this calculus class, and we use these with her, to show her different things. But I didn't ever think about using it to explain the power law. And then, yes, it was really cool because we could show a lot of things that maybe people have problems sometimes in understanding it. And I felt, oh, this is so amazing. We made so much progress. So this is what I want to do. I want to kind of recreate what happened yesterday because it was kind of one of these aha moments, where you see people finally getting it. That is so cool. As a teacher, it's one of the best reward possible. So it's really cool because you can write anything. Like, for example, I can write X, right? And X, like everybody knows, it's a straight line. It's a straight line. It goes through the center. It's proportional. You see, if I get on the x-axis, I get 10,000. I get 10,000 on the y-axis, 20,000. I get 20,000, right? When I go to the negative value of x, I get negative value of y, etc. Beautiful, nice straight line. So what happens if I put, I don't know, I put 2 in front? If I put 2 in front, it's going to be faster, right? So instead of having 10,000, 10,000, 10,000 on the x-axis, 10,000 on the y-axis, I get 5,000. On the y-axis, I get 10,000, right? I get 10,000 here. On the y-axis, I get 20, right? This is how it works. If I do 3, you can see what you think, what is going to happen. 3, well, same thing, right? 5,000, now it's 15,000, and so on, right? This is what happened with straight lines. If I add a constant, everything will shift up, right? If I put 2, let's put a bigger number so you can see 10,000, right? Okay, it goes all the way there, right? It doesn't start at 0, it starts at 10,000. Because basically when x is 0, you will get 0 times 3, 0 plus 10,000. So when x is 0, I get 10,000. This is called also the y-intercept. So it's a really cool interactive app that is super nice. And what I wanted to show you is, a straight line. We like straight lines. Human eyes recognize immediately straight line. And usually, as a scientist, you do an experiment and you collect data, and then you plot the data because you want to usually, I am both a theorist, but also I did a lot of experiments. So I do an experiment, whatever experiment is, you measure the temperature of something versus the volume, whatever it is. And then you have all these data points that you collected, right? You have some kind of instrument that is collecting this data, and then you plot it to see, is there a pattern? Is there some relationship between one quantity and another? This is what we do in science all the time. And usually they will look like scattered, right? Because they never perfectly follow a straight line. But if they are scattered and kind of like follow straight line, then you say, well, there is noise, because there is always noise, even when you measure something that is very, very precise. Your instrument has noise, there is electronic noise, there is vibration on the earth, or maybe what you're studying is influenced, like, if you're measuring the velocity of a ball inside air, it will be affected by the air. There is like a little deviation, so there is we call it noise. And it could be also part of how the system works. It's possible there are two things, one that makes like with Bitcoin has both, we call it deterministic, when something behaves in a very precise fashion, and also stochastic. Stochastic means random. Bitcoin is both, right? It's stochastic at the local level. This is why we cannot use the power law to predict what happened on the daily level, because that is stochastic. So it's both. It's a stochastic or random at the local level. Local level means a few days or something like that. And also this this long term, we call it deterministic. Deterministic means more precise, more regular. You can calculate it and so on. You can have both. There are two things happening at the same time that describe this phenomenon that you're studying. So if you have a bunch of dots here and you see kind of a follow straight line, you can fit a straight line. You measure the slope, you create a linear relationship between these two things. And, usually you stop there. You publish a paper, say, hey, look, there is a relationship with these two things. By the way, there are a lot of things that if you don't collect enough data, they look like a straight line, simply because a straight line can always approximate something complicated. So if you look at a very narrow range of things, sometimes you get this straight line, but then, the phenomena is much more complicated. But, it's a good approximation of what is going on. And what happens many times when you don't get a straight line, maybe sometimes you get what is called an exponential. An exponential looks like this. It's something that there is some kind of process that is doubling or tripling. Let me make it slower. Okay, like this. So this 0.02, hopefully you see my screen. It's basically the rate of change, right? So it's something, anytime you have a process where you double or you multiply something, right? So imagine I have like a vial, a test tube with some bacteria, and I put some sugar inside, they eat the sugar and they multiply, right? Like bacteria do. So there is a typical time. It could be a day, it could be 20, 10 hours, whatever it is. They double every 10 hours. They double, right? And maybe it takes, I don't know, it takes 23. So we say, let's say that they double every 5 hours. Okay. So I'm going to ask this question to everybody. It doubles, because of the food they have. But, when they reach the maximum, because it's a finite system, right? They don't expand, they cannot go outside the test tube. They double every 5 hours. And let's say it took 3 days, 4 days, 4 days to reach half of a test tube, right? There is only half space left. How long do you think it will? And so basically it's 50%, right? We have 50% left. And they say it took 5 days to do that. How long do you think it will take to fill the entire tube? We have 50% left, and we want to fill the half of the test tube. And remember, it takes 5 hours to double. How long does it take to fill the entire tube? Anybody wants to try to answer? 5 hours. You see, this is how fast exponential are, because imagine it took 5 days or 4 days to reach the 50%, but because it takes only 5 hours to go another 50%, it takes only 5 hours to fill the rest, right? So this is how fast exponential are very fast processes. And our intuition is not like that, because probably we evolved where, like most of the things that we do are all for, like saving our lives when we were in the savannah, right? So if there is a leopard that is, trying to run after you, you kind of look at the leopard, say, okay, the leopard's moving in this direction, I'm going to move in the other direction. You calculate with your brain what you need to do, and it's all linear. It's not exponential, and so our brains are very linear, very linear. This is why we like straight line. And so we have, when you use your intuition trying to understand exponential things, we fail. This is why you need the training. This is why you need a calculator. This is why you need to spend a lot of time and build intuition, because you can build intuition, but it takes time. You have to spend time with these things, and then they become almost like second nature. But even somebody that is trained, it takes time, and you have to go back and forth between the math and the intuition and the math, go back and forth. It's almost like two legs, you walk and it takes time. Sometimes it takes, you get stuff. See why this is why some people give up. Say, I don't understand this. Well, try, do it a little bit. Maybe try an Excel, draw. You can get the data. By the way, this is a good place where to get data. It's called Bitcoinity, bitcoinity.com. It's one of a few places where you can go and download data on a spreadsheet, and then you can play with it. Why don't you? In fact, you know what? I'm going to give a free indicator, 2 indicators, to the one that makes the nicest chart, the one that is more nice and beautiful. I'm going to, let's give 2 days. Post it in my X, and we'll make a post after this. Say, post here your most. If all of them look nice, then I will do it by random. I will choose somebody random, and you get the 2 indicators, and you get free Discord access, etc. So let's make a competition. Get the data from bitcoinity.com and plot. I want to see beautiful power law charts. Everybody needs to do it. If you have time, of course. But the winner, I will try to use my judgment, whatever looks nice and maybe has more details or something. You can put the halvings, whatever. And then the winner gets our indicators basically for life, free. Okay. And you also are welcome to join us in the Discord channel. And then, of course, everybody else can join our Discord channel. But I will give it for free, just to give you a motivation to do it. Let's choose 2 people. 2 people, the best to get this reward. But do it for you, because it's a way of understanding Bitcoin. It's not because of the reward. I'm just doing it to add some motivation. Okay, so let's go back here. And so Bitcoin is not an exponential. It doesn't behave like an exponential. When I joined Bitcoin the first time, and there is like an article there, that was the article that inspired me to become a Bitcoiner. The other, if you read that article, it's a lot of fun. I suggested to read it because it's 2012, and you can see how people were thinking about Bitcoin at that time, And this guy is a visionary and says, oh, it's going to be a big deal, etc. I never had doubts. Never have doubts. When I read this article, it was like a confirmation of some of the things I heard already about Bitcoin, and when I heard about. But I look at the chart, because there is it's one of the first model, like very early model, 2012, very little data that we had. And this guy says 2 things. There is one of these huge big bubbles that we saw before, right? Like the first one, it happened before the halving. And so he was saying, well, we had a bubble, because everybody was saying, oh, Bitcoin is a tulip. It's like tulip. It's tulip. This is what we were repeating. Right now, almost anybody says that because it's stupid, But at that time, we were saying basically it was a kind of a fad, and it will go up and then down, crashes, hurt a lot of people. It went up to like what, $10? Ridiculous, right? Now $5, whatever it was, the first bubble, and then it crashed it to $3, and people were screaming, "Oh, it's so ridiculous," right? So if you compare it with today, at that time, everything is proportional. Remember, everything proportional, right? This is what part of the scale invariance thing. At that time, it was a big deal. It was a big deal because everything was proportional. So this guy says, no, because usually tulips crash and then never recover. You see, look, we are recovering. We are going up. And in fact, he say, it looks like we are exponential. That it looks like a Bitcoin is exponential. And I look at this chart, I say, I don't know. I don't think so. And I started to study the data. This is when I started my adventure in understanding Bitcoin. And so I downloaded the data, I studied it, and I saw all this irregularity. But very quickly, I thought it's not behaving, it's something else, So I didn't know what it was. And I was exploring, understanding, looking. I thought very quickly, I found power laws in the other on-chain data, because that is the beauty of Bitcoin. We have all this other information. We have many addresses that are kind of a sign of activity of a network. And we have transactions, we have hash rate. So you look at all this other information that is all related to each other, and you start to see this pattern. For me, because that is one of the things that they train us in physics. When you don't see a linear, you don't see an exponential, the next thing you try, because usually in nature is these three things: is linear, exponential, and the other thing, power laws. Now, it could be that it's other things. Sometimes you have a sine wave, if it is cyclic, etc. But really, usually 90% of the stuff is these three things. And in fact, the majority of things in nature are power laws. And power laws are different, right? By the way, I tried, there is a way of showing a log graph. It's a little funny. It doesn't really work well, but let me show you first of all how an exponential looks. If I do the log, so here there is a way of going here, right? I go under this little branch, and I say I want to see logarithmic, okay? And I'm going to do it. I'm going to keep the linear axis, but I'm going to make the y-axis logarithmic, okay? So look what happens. And for some reason, that is what I don't like at this app. It's everything is beautiful up to, there is some kind of a bug where when you start to use these logs, it kind of a little glitchy and it doesn't show anymore the x-axis. And I wish there was a way to draw lines. I don't know how to do it. If you can, but the x-axis disappears. So it is a little, it's terrible because it's nice if I can go to logs, But look at what happens. That exponential will look like a hockey stick. If I take the log of the y-axis, it becomes a straight line. It becomes a straight line. And that is kind of cool because we use this trick to see if there is an exponential, because I see a hockey stick, what the heck it is, it could be anything. Then I do the log of the y-axis and it becomes all of a sudden a straight line. So it's a trick. We call it a transformation in science that allows us to go from something that looks like a hockey stick to a straight line. And why it becomes a straight line? Because basically the log is like, sorry, Mike, I need to drink something. The log is almost like the opposite of the exponential. They cancel each other. So something that is almost like I get in, like of the inside, right? You see, imagine I have something that cancel with exponent, with exponential. I get back what is called the argument, with basically what is inside. And inside, basically, you have a straight line, right? Because it's 0.02x. So basically, this is why you get a straight line, because the log cancel the exponent, and so you get what is inside that box. Think about like this exponential, like a little box, like a black box, and you get back what is inside. You open the box in a certain sense. So you get a straight line. It's a nice trick because we recognize straight line. It looks like a straight line. It means an exponential. So if you have some data and you don't see a straight line, then you say, okay, let me take the log of a y-axis. In particular, if these phenomena change, like imagine I'm studying all these animals and I go from a little mouse to have elephant, so very big different sizes. And so I need to span this big range. The log helps you with that, okay? And so you get this straight line. And now, if you don't see a straight line and you see something else, for example, say you have a parabola, what is called a parabola. Parabola looks like this, looks like x to the square, right? Okay, forget the negative part, and we can go back to that in a moment. See, in fact, if I go back to the linear graph, where I get back linear, and I have I need to zoom in to show you what happens. Okay, it was too much. Zoom out. Okay, a parabola looks like something like this, right? So, okay. Okay. So everybody's familiar with a parabola, right? A parabola, it looks symmetric, it goes up. It's almost like the hockey stick that we saw before, but it's gentler. It doesn't go as fast as an exponential, right? And we can understand what the parabola does, right? Basically, you see, I take the x and square it, right? So, for example, if I go here to 2, I take 2, I take the square, so this is the x, right? I get 4. I get 4, I square it, I get 16, right? I go all the way here, I get 16 with 4. This is all what it does. And it's symmetric because if you go on the negative side, you take 2 minus 2, you take the square, right? Because what that square means, it means you multiply, you take minus 2 times minus 2, it gives you 4, because the two negative signs, when you multiply two negative signs, they cancel each other, right? And so you get 4. So basically, it's symmetric because like this. It doesn't matter if x negative or positive, you still get the same value. And it's kind of a multiplying effect, right? These parabolas are beautiful because you put in one way of thinking about these functions is called functions. It's basically, if you ever, I like to think about that. It's like a box. You put like inside something, an input, and it gives you an output, right? The input is 2, I get back 4. And the input is 3, I get back 8, right? 9. And so on, because it's 3 times 3, right? 9. And so on. Like I put 4, I get 16. 4 times 4, 16. And so on and so on. And it's these are what a parabola is, okay? Now, many phenomena look like this in nature, look like this type of relationship where you have y equals some number, and that number can be anything you're studying. It can be, like for example, the size of an animal, and the y is the metabolism of an animal, how much energy the animal uses. It could be how many patents a city produces versus the size of a city. Many phenomena behaving this way, where there is one quantity versus the other with what is called the power. This is why they call power. This little 2 is called the power. I didn't make up this name. Power, I don't know why we came up with that name, because maybe something to do with multiplying things or whatever. It's a technical term. Or exponent. That is another name for that quantity, an exponent. And that number can be anything. It can be 1.3. It can be 3.5. It can be whatever number you like. Usually we divide between what is called linear or sublinear. It means if it is 1 or above, it's superlinear. If it is below that is sublinear. And it's actually very important because there are many types. It's almost like dividing the type of phenomena. There are some phenomena in nature that are super linear and they behave in a certain way. There are certain consequences of that little exponent. And there are some phenomena that have a number smaller than one, and there are other consequences about that. And nature decided, according to what happens, what this exponent is, because that exponent is so important because it's almost like a fingerprint for the phenomena that you're studying. It's one of the first things that we want to derive is that number, because that number tells us a story, tell us what is going on, what is the mechanism that is producing the phenomena that you're studying. And also, why they come up so everywhere, because it seems such a silly little equation. How is possible that all different phenomena from humans, and also please never say humans don't behave like equations. They do. We have hundreds of studies showing that even terrorist attacks. So don't say that anymore. It's not true. Science proven that it's not true. That doesn't mean that we don't have free will. Yeah, maybe at the individual level we do, but when we work as group and we interact, the interactions make us behave almost like particles. Now it's going to be more noisy because humans are still noisy and messy, etc. So it's almost like if you look at the phenomena that has to do with particles or planets, it's almost a perfect power law. Then you go to animals, you start to see a little bit more noise, a little bit more disorder there, like a little bit more randomness. And then you go to things like social events or financial events, and they are even more disorderly, but they are still behave in a very regular fashion. So don't ever say anymore this because it's not true. We've proven it's not. There are literally hundreds of studies showing it's not the case. I told you, even terrorist attacks follow power laws. And so this is what is called a power law. It's nothing else. So don't say you don't understand what a power law is. It's something like this. I mean, it's the simplest thing after a straight line. Do you understand a straight line? Yeah. Then you understand a power law because it's just the next step in difficulty. How difficult it is. You're squaring something. I just show you how simple it is. And it can be cube. Now, if I put 1.5, you cannot do that on your head. Now, why does it become like this? Why is bent here downwards? Because if you have a number that is not even, when you're taking negative number, you're going to get a negative value for the y. So instead of being symmetric, anytime that number is not, the exponent is not even, it's going to be non-symmetric. It's going to do the opposite on the opposite side. It still look kind of the same, but like if you flipped it downwards. So again, you can reason by the beautiful thing about an app like this, that you can fool around. You can be like a little child playing like a toy, and this is how we learn, by doing things. It's the best possible way. That's why I love this app, because you can fool around, you can play. I like this term play. When I study and I play with numbers, I always say to myself, I'm going to play, because it's really like a child. Your children are little scientists. You're going to be a little scientist, or a little like a child, or a child is a little scientist, the scientist is like a child, because they taught us at a certain point, like I want to tell you the story. We used to have, when I was teaching in college, these weekends where we will invite schools, like school children, and the teachers were bringing, and we will give them a demonstrations, in our physics department. About, it was like a local school. I was teaching in a local school, so we were all these local children, and they were coming, and we tell them about the planets. We tell them, because I was like the astronomer there, and so I was telling them about all these cool things about the black holes, what happened if you fall in a black hole, all cool stuff. And I noticed, if they were like elementary school children, up kind of to middle school, they were bright and they were jumping and asking questions, all excited. I could tell them anything, like, oh, look at this thing dropping. And they were like excited, and curious. Then they arrived to high school and everybody was like dead, like a zombie. I don't know what happens. I don't know what happens. It's so weird. Something a little bit of that happens in Italy. And sorry if I put down Americans. It's something about educational system. You have a bad educational system. Right? That your politicians need to. It's another thing that centralized decision makers. But something happens where you can tell them a most amazing thing. Look, I'm falling in a black hole, and you're trying to excite them, and they are like that, like you're almost like bothering them. They have to come there because their teacher told them so. But otherwise, you can tell them the most beautiful thing in the world, and they get bored. I don't understand it. I was not like that when I was a teenager. I was like, whoa, I'm all this stuff is so cool. I saw these Sagan programs. I knew that I wanted to be an astronomer and physicist, etc. It was all exciting stuff for me. But anyway, so you're like a child when you're exploring this thing. So it's really cool. And, like I can put a tree and you can see what happened. It became steeper. As if this number is bigger, it becomes steeper and steeper, right? So if I put, see, this is so big that it's a kind of a deform. But 8, it becomes faster and faster up. And if it is an even number, it's going to be symmetric. If it is an odd number, it's going to be not symmetric, right? So you can learn all kinds of things. I can put, let's go back to the parabola. I can put a constant in front of it. It is going to slow it down. If this number is a small number, if I do 4, right, 5, you see how that number kind of changes a little bit, right? Because imagine here, for example, 0.4. Okay, let's see what it does. This will have been 4, right? Because 2 to the square gives me 4, but because of that 0.5, it cuts it in half. And so it's 2 instead, right? And then if I go to 4, I will expect 16, because 4 times square, 4 times 4 is 16, right? This is what the square does. But because I'm cutting it in 2, it should give me 8, right? You see 8 here. So that is what that constant does. So this is actually the general form. So in nature, there are a lot of things called power laws. They look exactly like that. It looks exactly like that. And that number can be, like, for example, there is this famous formula that relates the behavior of animals, right? It's basically you have on this side, you have the mass of an animal. From you can go all the way to the cells, even cells scale up in that way. Another word that we use is scaling, because it's basically telling you how something changes as you make it bigger and bigger and bigger as you change the scale. And it turns out that number is 3/4, right? Here on the y-axis, you will have the metabolism of the animal, so basically how much energy the animal is using. And then as you move along the x-axis, this will be the mass, right? We are going to have the mass of small mouse, and the mass of a cat, the mass of a dog, the mass of a cow, and until the elephant, and it behaves like this. Now, unfortunately, and what is the relevance of this 3/4? I explained it before in some of my posts, and I don't know if it is 0.5, it's some number, but I'm putting there 0.5, whatever that is. It's going to be some number. I don't remember what it is. It's not that important. What is important, remember I told you, it's kind of a fingerprint, is this exponent, the power. So if you study with power, it tells you something about the mechanism. It tells you like a story. The story here is, if I double the size of an animal, the energy used is not going to be 2 times, because this is what you will think, right? I'm making the animal bigger, kind of I double the number of cells. So the cells need to be nourished. They need 2 times more energy. It turns out that the body, the physiology, organizes itself through some complex mechanism. In fact, it is a network. If you can think about an organism like a network, because we have all these cells communicating, transmitting information. You do this, I do that. I give you this nutrient, you give me this building material. It's like a living city, right? I don't know if you ever saw these simulations of even internally to the cell. The cell itself looks like a little city, and there are all these activities going on. It's a network. It's what is called a network. There is an exchange on information in a network. Every element is called a node, and the information, the link is called an edge. And we study them scientifically. There are all kinds of mathematical properties about them, how they grow, how they transfer information. There is an entire science of networks. There are big, huge books that you can study. People publishing papers. It's a science of networks. And somehow nature organizes itself where that number, instead of being one, that means you double the size, you double the metabolism. It turns out, by the way, it's so interesting when you see these charts, probably you saw, it's called Kleiber's law. You can actually Google it. If you go on Google, look for Kleiber's law, and you see this beautiful chart that, by the way, looks like a straight line, and we'll tell you in a moment why it looks like a straight line. But in a normal regular graph where you have the x-axis linear and the y-axis linear, it looks not like a straight line. It looks something like this, something that flattens out, right? And the reason is because of that exponent. It's going to be slower than a straight line. So this y is curving down. And the reason is, the consequence, not the reason, but the consequence is that is going, as you go up in mass, you don't need to have as much energy. And human beings, by the way, they will be, because energy, it's basically energy per second. So what is called the power, it's actually doesn't have anything to do with this power. Sometimes, in science, two terms can mean two different things. It's the energy consumption, energy per second. That is called watts is the unit, and power is the physical quantity. So basically, as much energy you consume per second. Humans are 100. It is like a bulb, right? We need the same energy of a bulb. How strange and curious to think in that way, right? That we need the same energy of a bulb to survive. Most of the energy, by the way, is from the brain. And it turns out here, in fact, we could even figure out what the initial number will be, because if these are kilos and these are watts, we will need to make that number small enough where on the x-axis we get like what a human is, it's basically 100 kilo, so we will need to make it smaller, but doesn't matter, right? Doesn't matter. You understand what I'm talking about. But the consequence is basically you save energy as you make the animal bigger and bigger. You save energy. In fact, by the way, you go to something like the elephant. The elephant is about, I think I kind of calculated the other day, was 100,000 the size of a mouse, but it uses only 10,000 the energy. And that is almost a saving of 10. And so in comparison, if you just scaled it linearly, and it's fantastic because we will literally not have elephants, because if you ever see an elephant, they are always eating because they need to get so much energy, and they will not be able to eat enough to survive. And so we will not have these beautiful creatures called elephant if it was not for this law. See how important and fundamental power laws are. Very simple equation like this. Look at this. And to explain this simple little stupid equation, this is why some people say, how can it be that Bitcoin is this little equation? It is. And if animals organize themselves in terms of their physiology, how much energy they use, it is so fundamental to survive, Bitcoin can do the same thing. This is one of the mystery of nature, that a simple little equation like that can explain so much. And studying that power, it tells you very powerful insights, because then as a scientist, you don't stop there. Well, now you understood, there is some kind of economy of scale as you go up and up, and the animals, somehow nature found a way of making these bigger and bigger animals by saving energy. And there are reasons why that happens. We don't have to go into details, but you can explore. It's one of the things that we do in our Discord channel. We try to understand these things because they are interesting about life in general. And but from understanding the math, it's like scientists don't stop there. They say, hey, okay, so how is it possible? What is going on there? Let's try to figure it out. And they that starts deeper explorations in this topic, and you can spend you can publish many papers, you can spend many years studying this thing, understanding better animal physiology, all kinds of different things, all from this silly power law. Kepler, that found how planets move around the sun, and it was like one of the biggest achievements of mankind. Guess what? It's a power law. And how do you find it? Remember I told you the first thing you try, always linear, when you go to the graph and you do the log of a y-axis, and if it is a straight line, it's an exponential. These power laws, and this tool breaks a little bit, because what you will see is all of a sudden now the x and y axis is a glitch. I wish was not there, but it's still going to make my point. Now look what happens. Some magic. See how this thing is bent? I'm going to choose the logarithmic and then the logarithmic. Both logarithmic, log. Look what happens. Same equation, didn't change anything. Look what happened. A nice straight line. We lost the y and x axis for some reason. Somebody needs to contact this guy, say, hey, please fix the glitch. But it's still showing it as a straight line. And it's some simple math. And if you come to the Discord, Friday, I have intention to show you the math. At least once in your life, you have to see it. It's not very difficult math. It's just simple. It's actually part of, the rules. If you studied in high school, it's the log rules, where basically, if imagine I apply the log on the y-axis, apply it here on the x-axis. And so now instead of having x, I have a log of x. And so this guy comes down, because this is what happens when you have logs. I can bring down, because of the log rules, this 3/4. So that 3/4 becomes like the slope. This 0.2 becomes like a constant. It's becoming now 10. It's becoming the log of 0.2. And it's going to be kind of a y-intercept. It's going to be the y-intercept of, we lost the y-intercept for some reason. But if we went to the y-intercept, we will be able to see that it's basically the log of this number here. And so it looks like a straight line. It looks like m, where is the slope, and that slope will be that exponent, times the log of x plus a constant, and that constant will be the log of 0.2. And so it looks like a straight line. And the beauty of seeing a straight line is that all of a sudden we recognize it, say, whoa, this thing cannot be by chance. It's some very regular pattern. And this is what, if you Google Kleiber's law, you see a straight line, because they plotted in a log-log graph. And you see all these animals on the straight line. If you're a scientist, I don't want to say a bad word, you literally get an erection if you're a male, or whatever equivalent is that, right? You really get excited, because I know it sounds nerdy, but it's beautiful. It's beautiful. It's like, what happened here? Nature is organizing all these things so regularly, etc. I want to understand it. I want to understand what is going on there. This is human nature. You're alive, and you are like, if you are not killed during your high school and you became a zombie, you're like a little child. You want to understand. You jump up and down. Fine. I want to find out. Okay. So this is what is going on. And this is the beauty of using the log, because it's evident that there is something going on here. It's a regular pattern. It's a precise pattern. It's not on a straight line. Remember, this thing is curved, but it becomes a straight line when you go in the log. This is a big deal about the log. And this is what I did with Bitcoin, because I look at transactions versus price, and they look like this straight line, because I knew about the power law. It's one of the things they teach. We are almost like fixated. It's like, in fact, I don't know if you ever saw this joke. I have this joke. It says, somebody has a t-shirt. They say, I went to a physics conference, and what I got was a lousy power law. It's a joke, right? Because we are so a little bit too in love with these power laws that they come up all the time from everywhere, but it's also, it's a serious thing, because they really are everywhere. I didn't make this universe. It's like that. And so it's a tool. It's like a microscope. You use this tool to bring out the signal. Sometimes also hear some people, they don't know what we're talking about. The internet allow everybody to say things, okay, this just came to my mind, I have to write it down, and you don't know what you're talking about. Some people say, oh, you did a manipulation of, yeah, exactly, I did it because we do it. It's one of the tools that we have. It's like looking at my microscope to bring out the signal from the noise. If I focus on the noise, I will not be able to see the signal. This brings out the signal. The signal here is that there is a power law, that the data is connected, the Y and the X, they are connected through a power law. And so it's a way of reducing the noise and bringing out the signal. You're focusing, you're putting your attention on the overall change, on this many scale, many order of magnitude change, and you're seeing out, you're almost taking an airplane and you're seeing the forest instead of focusing on the tree. The forest looks like this, so it's not a trick, it's not drawing a stupid straight line, it's doing science. It's a big deal. And the fact that it's simple, it's actually the opposite of what people think. It's something that we use in science all the time. When if you have two description of nature that some scientists giving, and one is complicated and the other simple, we always choose the simple, simply because nature, this is what nature likes, like simple things. And by the way, why they are so common? They are common because anytime, and again, it takes a little math, but it's not complicated. But let me tell you in words. Every time you have a phenomena where your input has an influence on the output, and the output has an influence on the input, so basically what is called a feedback loop or iterative loop, you get power laws. You can show from the math. They come exactly from the math. If you write an equation that shows how the input has an influence on the change of this input, the solution for that equation is, the technical term is a differential equation, but don't get scared by the term. It means a differential equation is an equation that describes the change. In physics, we are very interested in how things change. We want to describe how things change, how they evolve in time, etc. Right? How a particle moves, how a planet goes around the sun. This is what we do in physics all the time. We use this equation called differential equation because we're equation that talk about how something changes. So if you have an equation where the change depends on something, and what is changing is that something, that type of equation is called an iterative equation, and it's one of the possible differential equations. That equation has a solution that is a power law. So if you have a phenomenon like that, imagine, I'll give you an example. Take a tree. A tree is going to have a certain number of branches, right? Come spring, they have all these little new branches coming up. The number of branches this particular spring depends on the branches that were developed last spring, right? So they change and change and change, and whatever state the tree is, the number of branches now depends on the branches in the past. So this will be an iterative process. And there are many in nature. You can think about many. And in Bitcoin, there are all over the place. Think about the number of Bitcoiners. More of us, more there will be tomorrow, right? We spread more information. Everybody's telling some friend, etc. So how many Bitcoiners we're going to have in the future depends on how many Bitcoiners we have right now. Hash rate, same thing, right? Because of the difficulty adjustment. If you have a lot of hash rate, that is going to create some response from the difficulty adjustment, and then the difficulty adjustment asks, you will need more hash rate, or maybe you reduce the hash rate because otherwise it's too expensive. So it self-regulates like that. And so anytime you have an input that becomes the output becomes the input in a circle like that, you are going to get power laws. So I post this on time and say, it will have been weird if we didn't find power laws in Bitcoin. What is the fascinating thing is that hash rate is a power law, addresses are a power law, price is a power law, there are power laws of power laws. Bitcoin is this power law, fantasy that, physicists got crazy. Okay, this is why I don't listen to economics people. It's not an economical thing, it's a physics thing. This is my advice to you. The economists, if you want to understand Bitcoin, they need to start to pick up some physics book and learn about these things. Okay, let's go. I'm going to take 1 second break and see if anybody survived. People are dead, people are leaving, everybody's bored. I'm going to take a couple of questions, and then let's dive in and let's look at Bitcoin. Let's look at the power law that we all love, that is Bitcoin. Why zero draws horizontal? Oh yeah, that is so clever. You see, this is why I love to interact with you guys, because you tell me stuff that I didn't think about. CE is saying just draw another line, y equals 0 or x equals 0, and then you get your axis. Yeah, exactly. We can do that. Yeah, so cool. You make me think. This is why I love teaching, because the student tells you something and you think about it, and stuff that you never thought about before. So this is why. And everybody, right? It's not that I am the teacher. There are times when I am a student and you are the teacher. It's roles that we take. And we teach each other stuff. But that is a beautiful thing. I can do that. Yeah, that is such a good advice. Thank you. Economics will be as alchemists. Yeah, exactly. And there is an entire branch called econophysics, because physicists started to get tired of this BS, say, hey, let's make our own discipline where we're using all these tools and we're trying to understand humans and all the interaction. They use tools from the past. And if you think about it, some of these tools were also linked to politics, because a lot of politicians hired economists that, to be basically kind of like to justify the things that they did. And it also was based on, trying to kill each other, having wars, and Bitcoin is all the opposite of these things. It's teaching us, be patient. I can grow fast, but, I'm doing to do it on my own pace. And all this, nobody can mess with me. It doesn't matter what you want to do. I'm going to do my own thing. It's all different from all the concept, so when people say, oh, but this concept in economy, I don't want to hear. I don't care about what other economy, it's many times to say I should study, maybe I'll pick up some economy books, because when I talk about something, I want to understand it. But then I get bored because this doesn't apply to Bitcoin. I want to understand Bitcoin. Why should I waste my time trying to understand what happened in this market, of toilet paper, when I'm interested in Bitcoin? So I want to study Bitcoin. If it doesn't apply to Bitcoin, I don't care, So I want to focus on Bitcoin, what Bitcoin does. Anyway, so let's go and let's study Bitcoin. So what is Bitcoin? How is the power law for Bitcoin? And I told you there are all different ones, but let's go back to the linear first, and then we can do the trick that you guys told me to put some arbitrary lines that are going to be our x and y, and we can look at what happens when we go to the log space. But let's start with linear, okay? So the equation that I found, and when I found this, I almost fell from the chair. I thought, what the heck? What is going on here, right? Because it looked like, you saw that graph, right? This is why I started from that graph. It looks like the general direction, it's a straight line. This guy, H.C. Berger, I don't know if you guys know him. He's like somebody, very clever young person, handsome guy. He saw, I think he's a computer scientist, and he saw my Reddit post, and he thought I was an idiot, because I thought this guy did some mistake. Or look at this, I never saw Bitcoin like a straight like that. So sure, he wanted to comment and tell me something bad. I'm exaggerating. I'm making up a little bit. I heard him telling the story. I'm making it bigger than it is, but he kind of got almost upset with me, because of it. So the charts, this has to be a stupid guy that did some mistake. And then he started to look at it more carefully. And first of all, my name on Reddit is Econophysicist1, and so I thought, okay, if this guy is really a physicist, and he noticed that there was the log and time, that is really unusual. Not many people do. In physics, we do it all the time. I had economists. There was at a certain point a guy that wrote, because what happened, once he saw that, and he saw that I was not getting traction, he said, this guy needs more, but Bitcoin. I don't care about me. He wanted to expose this idea that we need to plot Bitcoin in a log graph, because look at how regular it is. It's also a tool to orange peel, because when people tell you, oh, it goes up and down. Anytime I talk to people that don't know about Bitcoin, they say, yeah, I remember it was a thing 5 years ago. What the shit? And then it crashed, and these are the only thing that they remember, that it crashed, And so, which crash are you talking about? Look at this thing. It's a unstoppable train going up and up and up and up. Look at this thing. And they immediately look at the thing, and they realize, what the heck, what is going on. They don't even need to know that it's a log graph. You can tell them, Dean actually is faster than this. This is a log graph, and you can tell them a little bit, but immediately you see that graph and you realize something is going on here. This is different from anything I ever seen. And in particular, if you show one of these graphs where I show how NVIDIA looks like, how SP500, it looks like Godzilla versus these little mice. In comparison, when you plot it in that way, it looks like enormous. What Bitcoin did in these 15 years in comparison with all this other garbage. And so it's a powerful thing. And so this guy tried to make it popular. He wrote his own Medium article. A lot of people started to talk about this. Was more or less during S2F, and because S2F was getting all this attention, and you know what I think about. No, I know about S2F, but it's based on an illusion. It's basically rediscovering the power law. Plus, he adds all this stuff. But let's not talk about that, okay? Because people get mad when I put down other people. Let's focus on the positive things, on these. And so, and he showed this stuff to people, and he was like so amazed by this behavior. And some people associated the model with him, but he has been always straight, saying, this I got it from Giovanni. I wanted just to give him exposure. I was trying to contact him. Eventually, we talk with each other. But basically, the big breakthrough for me was I looked at all these other things, like hash rate and transactions. So they were all power laws. But I will always do like 2 or 3 steps to then I will use some kind of S-curve for adoption. I was trying to make sense of the data, and at a certain point, it came to my mind, let's plot the log of time and the log of price. I don't know why it took me so long time, but yes, this is what I was trying to say, because I'm always going in 10 different directions. When he published that article, there was a couple of people, one less prepared, because he's kind of think it's like a graduate, like maybe somebody that graduated from economics relatively recently, and then there was some more senior person that wrote an article basically, debunking this. What are you debunking? What are you debunking? Don't you see your eyes? A physicist will never think to debunk that thing. It's look like straight line. There is something going on there, trying to understand it instead of debunking, But this guy wanted to debunk, and one of the things that he say, how we cannot take the log of time. Why? I can take the log of anything. Actually, even was confused. We thought of it because we were dates. He thought of it that we were taking the log of dates. What? It's so stupid. Like that level of incompetence. It's like, I don't understand. What do they learn? What do they learn, these economists in school? I don't get it. And the other one was basically saying a bunch of bullshit. So I tell you, because if you ever see anybody, I didn't see anymore, because when I'm publishing my thing, I immediately say, look, this is what we're doing. I have an economist supporting me, saying that actually knows a little bit of physics, like this clever guy, and he say, you guys shut up. And he came to my rescue. And then there is an article published in peer-reviewed journal that actually is doing kind of the same thing, and say, no, if I tell you there is a cause, and there is, because their argument is this, when they're trying to debunk it, their stronger argument, they say this stuff is too correlated, and it could be that you're basically plotting 2 things that are obviously correlated. And so you basically, in Italy, we say you discover the hot water. Of course, these 2 things are going to be correlated, because they are not really causative of each other. But, like, for example, imagine I plot my age versus the price of Bitcoin going up, and then you say, hey, look, by aging, I'm making the price going up. I will be stupid, right? It will not be anything valuable because, of course, I age with time, the price goes up in time. Correlation doesn't mean causation. Many times, but other times, if I plot the time that it takes for an object to fall down and how fast it's going, of how much distance the object is covering, that is correlated, and you cannot say that time causes, but it's they are it's a process that happens in time. They also don't know how to play with time because they usually don't understand time like a physicist understands it. It's like a clock that happens in the background, and this thing is happening in time. So of course, if I make a plot of an object distance as it falls, is going to be related to each other. In fact, look what what it is. It's a power law, because the time at a distance, like if you had to draw it, it will look like something like this: 1/2. This is how the fall of an object. Imagine I drop an object from a certain height, so the height will be 10 meters, right? So it will be at 10 meters. Let's write it like this. Let's start from scratch. Yeah, because this is actually school. 10 meters, or 100 meters. I'm dropping an object from an helicopter. And then, that height will be smaller and smaller. So I need to subtract it, right? And it turns out the formula is something like this. Let's see if I can do it. It will be depended by what is called the acceleration due to gravity, that is 9.8 meter per second square. So basically, it's accelerating, it's going faster and faster, and it's that number. And then it will depend by the time square. So it will be the time here square, x is going to be the time, and to the square. Okay, so it will look like that. So, and of course, we don't have negative time. It will be only positive, so forget about the negative side. Okay, and so it will be like this. This is how much distance you cover. Guess what? If I plot this in a log-log graph, okay, if I go back to the log-log graph, imagine what it's going to be, because basically this square, right, it's going to be a power law. It's going to look like a power law. It's going to be like a straight line. And so this is what we have. It's that 100 will be a little confusing, so it's probably it's better to use 0, like, and then negative time will be basically going down. So it probably is better to plot it in that way. It's easier to actually see that it's a power law. So 9.8, okay. And so now, it's going to be positive, or we can make it even negative if you want, but it's basically like a parabola, right? And if I go to the log-log graph, it will look like a straight line, because this is what power law look like when you go in the log-log graph. And so if it was an economist, he will say, oh, this is spurious. How can it be spurious? It's a natural phenomenon, but this is exactly what happened. But they will tell you that it's spurious with their approach, because they use all this fancy math and they don't understand what is going on. And because most of the time what they deal with, it's random stuff that could be kind of weakly correlated one with each other. So we want to make sure that you don't state the obvious, that the two things that don't have anything to do with each other, and they are just by chance, like my age and the price of Bitcoin, and you are making a big deal about this, and then there is nothing there. But so they have tools to determine that. But in a situation like this, where they tell you that the phenomena that I'm studying is like a natural phenomena, your stuff doesn't apply. Okay, and I have also a mechanism, because now we know what it is, right? We say that it's due to the Metcalfe law. We say that it's due to the to the spread of information in a network. So we have causative explanations. So their arguments are worth nothing, and so it's good. You have to be, of course, always careful, and it's nice that there are people that are skeptic, but don't be as skeptic as closing your eyes and don't understand what we're even talking about. So this guy, when I wrote my article, I don't know if you read it on Medium, I have an entire section where I deal with these guys. I call them the autocorrelation bros. And so autocorrelation bros, I didn't hear many autocorrelation bros talking anymore because it's stupid. Whatever they say, it's meaningless. But of course, you want to be careful and understand the data, doing tests, etc. But and me, Berger, now there is this this astrophysicist guy that is friend of Fred. There is Scenes that is actually he's a finance professor, but he DM me say, I work with physicists. I know how you guys do things. I understand it now. I start to think a little bit like a physicist. I do things in a different way, and it's great because he understands the power law. He thinks he even say about the power law. Talking with Fred, I never saw anything like this before in any other data. I didn't see anything like this. Okay, how regular this thing is, how precise this thing is. What he did, he took like 50% of the data, then he made a prediction using only 50% of the data, and then he checked how the data actually behave in comparison with the prediction. And he said, it's amazing. I never saw anything like that before. So, more and more people are coming in. Eventually, I want to publish this paper, and there'll be more scientists saying, "Oh, you did a mistake. You did something stupid." I'm waiting for that, because I want to know. I want to know, is this just made up? But let's look at Bitcoin. So Bitcoin, it works like that. It's 10 to the minus 17, and I will explain in a moment what this crazy number means. And then you have X, okay, and then you have 5.83. They really is close to 6, but the real number is something like that, 8.3. And so what all this means? Okay, because many people get confused about this. What this means? It's actually not that difficult. Okay, what it means here, we have price on the y-axis, so it's going to be our y, and the x is time. And what do we mean for time? It's time in days, usually. We can use any time. You can do it years, you can do whatever. But this particular formula, is meant for time, okay? For days, sorry. And so it's days from the Genesis block. So the Genesis block is when the first block came out, basically after the Satoshi launched Bitcoin. And it's January, I don't remember the exact time, maybe somebody remembers, but the date is January 3rd, 2000. I mean, my students were always making fun of third because I will say, hey guys, here is the Newton's law, first Newton's law. Okay, everybody was serious. Then I would say, this is the second Newton's law. Everybody was serious. And then I would say, then the third Newton's law. And everybody was laughing and say, what the heck? What is so funny about the third law? And then one student came, he pronounced it like if it was something else, because in Italy we have hard time to pronounce the TH thing. So it was kind of fun. But you know what I mean for third, you have to put that TH thing. And then at a certain point I decided I'm going to say law number 3, instead of third. So funny. But anyway, it's January 3, 2009. And so it's the days from when it was invented. That kind of makes sense, right? Because if I want to describe the behavior of Bitcoin, it will make sense to do it from when it was created. So how much time is passed from when it was created. And look at this. Let's stop for a second and look at this formula. It doesn't matter that you get a little confused about that 10 to the minus 17 because it looks weird, right? That is Bitcoin. That simple thing. Like we can describe the animals with that simple formula. We can describe Bitcoin with this little formula. It's not crazy if this thing is really true. If it turns out to be true and other scientists confirm it, and we wait in the future and it still behaves in this way, it's one of the most amazing things. That this complex thing behaves in this very simple way. It's just unbelievable. It's like, what the heck? Now, what does it mean? Well, if you look at a chart, of course, right, it fluctuates, right? Because, like we said before, by the time you go from planets to animal a little bit more disorderly and noisy, you go to social things and financial things, it's going to be even more. But it's still amazing that even with that little disorderly and noisy behavior, in particular these big bubbles, right? Because it's not just like the fluctuation during the day, it's also these huge big bubbles. They go up, then they crash. It's also part of the history of Bitcoin. But notwithstanding even this crazy bubble, it still follows this overall path. So what do we mean with that? What this represents? It represents the general trend, the middle ground. And so we call it fair value, we call it trend value, whatever you want to call it, but it represents kind of like where Bitcoin should be if all this noise was not going around. And because sometimes the data is above, sometimes it's below, I did something, I don't know if you ever saw, where you average, it looks damn straight. It starts with bubble disappear, and you start to see kind of a little bit of oscillation. It almost looks like a snake. The price starts to look like a snake that is on top of this straight line. So it becomes flatter and kind of starts to go towards that straight line. If you average it over a month, over 10 months, 4 years, you can average over the entire period of time, and it starts to look more and more close to that straight line, because this becomes a straight line. Like, let's go back to the log thing. Just okay, logarithmic here, logarithmic there, straight line is where the straight line gets. You get a straight line, and the straight line, if you go all the way to the y-intercept, that minus 17 is the intercept, and the slope of a line is 5.83. This is how you actually derive it. People say, where did you get this number? I get it by doing the log graph, and then there are these tools. One of the tools that we use is called regression. It's basically a mathematical operation, that you can have a computer do it for you. Basically say, okay, this is the data, go and give me what it does. It tries many different combinations. So basically you define a straight line with two numbers. One is the slope, and the other one is the y-intercept. This is all what you need to a straight line. So you try many different lines. The algorithm does this for you, different line, and then you measure the distance of every single point, and then you take the average of every distance of the points that you have, in this case the price, right? You measure all the distances from this line, and then the task is, I want to have a line that minimizes the distance, the average distance of these points, because it's going to represent in that way the best, what we call the best fitting line. If there is like a linear behavior here in these logs, remember these are the logs of the price, the logs of the time, there is some kind of trend that is represented by a straight line, and the best fitting line is the line. It makes, sometimes having analogy helps. It's the line that makes most people happy, most data points happy, because they are the closest to the line, in average. So this is what this algorithm does. It's based on calculus, and it takes few seconds. It depends how much data you have, and it spits two numbers. These numbers are the slope and the y-intercept. And it turns out with Bitcoin, it depends if you include early data, if you don't include early data. And so that number can change a little bit, it can be 5.7 instead. But in general, it's close to 6. It's close to 6. And that number, the other number, the y-intercept, is a very small number. That is what it means, 10 to the minus 17. It's a very, very, very small number. And I will explain you the significance of that number. So let's go back to the linear chart. Okay, let's go. Oh, by the way, before we go there, I want to show you this, where I made the x-axis, and somebody, let's try to think with the guy, whatever, I can do y equals 0. Okay, does it work? Why doesn't show? Doesn't like it for some reason. I don't see that line. It should add it. Okay. I don't know. Oh, start to see it. Y equal 1. Oh, you know why? Because in a log, y equals 0 will be. Let's make it. Yeah, the log of 0 will not show. Okay, let me see. Okay, let's make it 1, just to give us a reference or whatever. So 10. So here, okay, these are not 1. Okay. But anyway, so you see how this curve, and maybe can we choose colors? Okay. All right, and you see how it's curved now. You know, this is Bitcoin, and you're familiar with this because it's basically what we call. Let's take this. It's distracted for a moment. So I don't know how to code it. But if I zoom out, let's zoom out a lot. Yeah, it has a little problems with this log thing. But basically, it's curved now like this because remember what this is doing when I take the log of the y-axis. It's supposed to represent exponential growth. So an exponential will look like a straight line, and anything that is lower than an exponential will look bent. Okay, so it means that it's losing ground relatively to the exponential. It doesn't mean that it's bent, because when we go to the linear chart, you will see it looks like an hockey stick. It looks up, it's almost the power of 6 of time. So it's really fast. If people say, oh, the price went parabolic. Well, parabola is square. This is super parabolic. It's much faster than normal parabola, right? It's 6. So it's going to look like a hockey stick on the linear chart. But here, in this chart, the rainbow chart that everybody's familiar with, it looks like bent. It looks like it's tapering off, but it's an illusion. It's an illusion because we are using the log on the y-axis, and anything that it doesn't grow as fast as an exponential will look like it's slowing down. It's slowing down relative to what? Relatively to an exponential. So let's go back to the normal chart, the linear chart. And now we really need to zoom out a lot because it's so, with 10 to the minus 17, it kind of temper a little bit this hockey stick. But look at this, right? This is how fast Bitcoin is. This is how fast Bitcoin is. This is how crazy Bitcoin is. Okay? It's going up very, very fast. Now, initially, it doesn't look like it's going fast, right? It looks almost like it is flat. And so now what do we have here? So basically, we don't have labels, but imagine these are days from the Genesis block. So many old Bitcoin is 10 days, 100 days, old, like a baby, right? And then 1,000 days. 1,000 days, there are about 300 days in a year, 356, right? So 1,000 days is almost like 3 years, right? About 3 years. And then this will be 6 years and so on, right? Right now, and somebody can even look it up on the internet, one thing you can do, you can always say how many days, right, today, right, I already have it here, how many days today from January 3, 2009, 5,576, okay? So what this equation says is you give me a day, how long Bitcoin has been around, how old Bitcoin is, and I give you a price. I give you a price in dollars. And so what do? You take that number, you raise it to that value, and then you multiply by 10 to the minus 17. 10 to the minus 17 is a small number. What is the meaning? Because many people ask. Well, let's see. So we can ask with this equation what Bitcoin was at any time. You give me a date, I give you a value. So if I ask everybody, let's see if anybody can answer this question, even to see if anybody's still alive. What was the price of Bitcoin at 0 day? When it was 0, when time was 0, so the day that Bitcoin was created. See if I find you. Okay, anybody was, can you tell me how much was worth Bitcoin at day 0? Anybody looking at the equation? Remember, we can put 0 there in the x, 0, right? Because if we put the 0 in the x, 0 to the anything is always 0. 0 multiply anything is 0, so 0. When Bitcoin was created, was worth it 0, absolutely 0. Now, how much was it worth it in day 1 after 1 day? Anybody? You put 1 there, right? When you remember, and you can round it up to 6, so you can do it, because 6 means you multiply 6 times. So if I have practically 0, but actually you can give a precise number. Of course, it's a model, right? It's not real. Also, what the heck it means, to be valued less than, like nothing, but 10 to the minus 17. No, not 0.53. Well, whatever that number is, 10 to the minus 17, right? Because x, if let's say that it was 6, that 5.36, let's round it up to 6. It means 1 times 1 times 1 times 1 times 1, 6 times, right? You're multiplying 6 times, but 1 multiplied 6 times is 1. And so you're left with that minus 17. A small number, so basically means 0. In fact, that number means 0.16 zeros 1, or 10 to the minus 1 is 1 billion. So that will be 100 million billion, something like that. This is how much Bitcoin was worth. That is what that question means. It means that if you give me any day, I can calculate what the value was at any day. Now, is it an approximation? Like we described, it's a general trend. But it allows even to calculate the value of Bitcoin when nobody was selling it and trading it. It's a theoretical value, but it's interesting. Now, the cool thing we can ask, right? We can go there to the graph and zoom in and say, you can ask all kind of, like, again, we are little children, we play, let's play around. We can go see. The cool thing is that I can move the cursor along here. I can click on with my left thing, and it gives me the first number is the days, the second number is the price, right? So one thing I could be curious about is how long did it take? Because it was so small, it took some time, right, to actually be like $1. So I can zoom in, and I invite you to do the same thing yourself, because it's fun. Because now you're playing with Bitcoin. Now it's Bitcoin, our little love affair here. So I can scroll until I get close enough. It doesn't matter. $1, 824 days. It took 824 days for Bitcoin, according to this model, to become $1. Okay. I will wait for you to go online, and let's see who is the first person that tell us how long did it take the real Bitcoin, not the little toy model that we have here, but the real Bitcoin to become $1. Anybody? Can you look it up? About 2 years, right? In fact, we didn't even calculate the precise amount. I think somebody told me 900 days or something like that. 600. Yeah, close to 900 days. Because it was February 2011. And so let's see how much 800 days, what did we get? What was that number? Anybody remember? It was, and it doesn't matter, I close to this because all this, it's just an approximation, but okay, let's use it, right? 824. So I can calculate, right? 824 divided 365, because there are 365 days in a year. Right? It's what is the result? Do we get it or no? It's about 2.2, right? Is that correct? Yeah, 2.2. Okay, you see? See how crazy this thing is, right? So it's basically, the equation is telling us that it's going to take, according to this equation, that amount of time that is extremely close to the real value, right? It took about 2 years, and the equation say it took about 2 years, to reach that value. It's not crazy. It's completely crazy. And you can try yourself and do 10 years. You do, $10, so how long it took to go $10. Again, you scroll there until you can try to do it. And it starts to become a little bit imprecise because at a certain point we have these bubbles, depends where we are in the cycle, etc. So we could be a little bit off, but you can see it's pretty good. Let's try together. Anybody can you look it up when we reach about $10? When it was $10, it didn't take much longer, because it was start to go pretty fast. So it was it took 800 days to reach $1, so parity with the dollar, and it took a little bit longer, about 1,225. Anybody can look it up when we were. It was also in 2011, right? So a few months later, and you can see, that will mean a few months later, because there are about 30 days, right? So in a month. So you can compare it. If somebody can do an exercise where, okay, this what the equation says, this when it happen, you can make a table, for like major event, and you can see they match pretty well, very well. In particular for being such a simple, 8 months later, and probably very close to what we just did, right? You can compare it. Somebody can create a spreadsheet and you can post it in my account so we can explore it together. It's pretty cool. And today, you can always ask, right? You can always ask Google and say, how many, in fact, I had it here. Let's see if I find it. I had it here somewhere. How many days? I have it here. I have it open. How many days we are from January? You can, this is how we do it usually. Say how many days, because Chat GPT, I use sometimes GPT-4, but by the way, it's a great tool to play with Bitcoin stuff. And you can even draw this thing for you. You can say, draw me, if you have a paid version, you say, draw me this equation. This crazy guy said, this is the equation of Bitcoin. Can you draw me a chart? And he can do it for you. I think you need to give it data. You can play around. But you can use Google to get many days from any date. In fact, you can say today. And today is about 5,576. Okay, let's go back to our chart. Okay, if I find it, where is it? Chart. Don't betray me right now. Be patient, I will find it. I have too many things open. Where are you, damn chart? Okay, I found it. All right, so let's go back to the chart, and you're still seeing my graph, right? I think you still see my graph. And I zoom out. I'm going to look for that day, 5,500, whatever it was. Okay, so I'm going to look here, 5,000, 5,000, 5,500. Let's round it up. There is no point to look at the precise value. Okay, 5,000. Okay, so kind of, let's take a reference. I could even draw a straight line, but 5,500, kind of in the middle of these squares, right? These squares will be, here is 5,000, here 6,000. So in the middle will be 5,500, right? Remember. So how I zoom out. Okay, it's changing me the scale here. But basically, if you do it, in fact, actually, you know what? I can do this. Yeah, probably that is the best way. I can do this. I can go through the cursor, 5,500, 5,500. What did we say? Something like that, right? This is more or less where we were a few days ago. Today, I don't remember exactly, but more or less, right? Look at the price. 67,275. Is that close to where we are right now? Yes or no? Yes, right? This is how cool this thing is. We just tried few dates and early on, we can try the other one, but look how close we are right now to the price today, over a span of 15 years. And you can play with this, and you can go up and down, you can different value, you can say, okay, when you can look it up, how long it's going to be before it becomes 100,000. Remember that is the average value. We could be up, and usually what happens also, we are about 50% when it's bottoms. That is also the other thing we say. Oh, but because it changes so much, it's not the model that changes. Bitcoin that does these crazy rides, So talk to Bitcoin, not to me. But even that is precise. Why it's precise? Because we know it's so regular that it's not that. See, that is another point of confusion for people, because there are some critics that do all kind of things. They come up with all kind of excuses not to trust this thing. It's not that you're trusting me; you're trusting Bitcoin. And if you study it and you're trying to understand and you use all these tools, you find out there are also these regular things. It's not that arbitrary Bitcoin oscillates like crazy through these lines. It does it in a very precise fashion. Most of the time, it stays actually below there, and you follow the power line for 2 years, almost like I don't know if you saw some of this graph. I can show it. It follows the power law to the dot. Of course, with oscillation, etc. But during the bear market, it stays below the trend, and it stays on this line. And so actually we go up. We go up for 2 years on the power law, and we stay there, and we never go below by a much. And that power law, that line, it's almost like if it were two power laws. So, there is the trend, and then there is this bottom power law. And we spend 2 years there. It is a long time to stay so regular, with little fluctuations. Sometimes it's a little bit off, sometimes, but there have been like 2 cycles where it was like almost scary that it was following that thing. And then the last cycle, he left it a little bit, and then he jumped down during COVID, and then he went up, but it's still a reference point. So he spends 2 years in this area, and then he leaves usually after the halving. Right now, we're a little bit more bullish than usual, probably because of ETFs and so on. But the ETFs are not changing. I made a calculation showing that the ETFs is just what we need to go to the next step. It's nothing unusual. Again, it's one of these proportional things where when Mt. Gox came about, it was a big deal at the time. When Outstock, I think the store, they accepted Bitcoin, was a big deal. Everybody was talking about that. We had all these events in the history of Bitcoin. It's almost the other way around. It's Bitcoin that is attracting this event because it's the right time, at the right place, at the right moment. So ETF is just what we need. And I even calculated, before I was saying this without even calculating, then I went back and I calculated this is exactly what we need to go to the next step, to go to the $1 million where we want to go. And so it's nothing that is going to change. But, because there is a lot of enthusiasm, people don't understand these things. They think that it's a big deal. They're a big deal. They're a big deal in the sense that it's just exactly what we need right now. But people get excited because they don't understand logs, they don't understand scaling, and they think there is much more there, and it's okay, they get excited, and maybe we have a nice bull run, and it's great, it's fun. But we are not going to change the overall trajectory. But they could push a little bit the peak to, where it should be. Instead, it goes a little bit higher, and we are a little bit more bullish right now relatively to other places in the cycle. But it's not random. It's all organized in a very precise fashion. So when people say, oh, but you cannot use predict, we use it to predict. We use to predict where we are in the cycle, we use to predict when we are in the bottom. I put it in my X, that I predicted the bottom in the past. I say, hey guys, we reach, because they happen about 50% deviation from the trend. So we know even where the bottoms are. And the tops, they are about 2 times bigger than the deviation. And we know also when they happen. They usually happen, in this fashion where we have 2 years at the bottom, 1 year to climb. So it's a cycle, very precise cycle, and then it takes 1 year to go down. And that, for example, for this cycle is going to happen around November 2025. This is when we are going to reach. Now, is it going to be 15 days before? It's going to be a month later? We don't know, because of course, there is always some variability there. But it's pretty damn good. And also, you don't need to know exactly when, because by the time you can put bands, right? So these are, I don't know if I can share. I can probably share that. Before I do that, before I show you all the things that we can learn from the cycle, etc., do you have any question? Because I don't want to switch. If you have any other questions about this thing, this Desmos, I invite you to play with it because it's so fantastic. Put this equation. It's the equation of Bitcoin. Everybody should memorize it and then play with it. Go around that red line. Say, okay, when Bitcoin reach $10, when it reach $100, make a table. See if it is similar to what Bitcoin really did. And remember, sometimes it can be above, sometimes it can be below, depends on the cycle, but it's pretty damn good, Yeah, we have a theory. So if you go, I show you here, okay? I wrote an entire article. Please read it. Also, there is a beautiful video in the article. My son made these beautiful videos about the theory, so it's really cool, very inspiring video. You will love it. And I will give you the link. Go to the article, read it. It tells you everything. And I will tell you in a moment the summary. But read the article when you have a chance. You don't have to read it all. And there is also a Q&A in the end where I address different questions and so on. And if you have a question that is not covered in the Q&A, write it in my X and then I will add it, because I want to cover all possible. Oh, welcome. And I love it. It's like when I talk about something I love, I never stop. My voice is going away, but hopefully I'm not boring you, etc. But the publication, I'm writing a scientific article and then I will publish it. I will need to find the journal. I don't want to publish in an economic journal, probably a physics journal, maybe Nature if I don't. I saw papers on Bitcoin in Nature. Nature is one of the top journals in the world. But they are mostly negative about how much energy Bitcoin uses, all bad articles. And hopefully maybe this will be a beautiful article. So I will try, if I reject me, I will try another. There is it's called Physica D, that it's all about applying physics to social network, applying physics to human phenomena. And so I can publish there. I think they will accept it. But also what we do often in physics, we have this place that is called the preprints. And it's not really peer reviewed, but you have to be, like, you cannot be a charlatan. They don't allow, random people to publish there. But you do it, to kind of announce that you're in the process of peer review. And so you publish it before you get peer review. So you can, when I'm ready, you can read it there, but then I will actually send it to a real journal. Because I think it's an important discovery. But basically, and you guys are, in fact, I will mention it if they allow me to mention, say, thank you very much, everybody on the X community, because you did it too. You were a part of this discovery, because by interacting with you, I discovered this thing, because I didn't do much progress in all these years, even if I started in 2013. I made so much more progress in the last 2 months by being active on X and interacting with the people, because you were giving me all these intuitions. And one night I was thinking about this 6, because where the heck this 6 come from? What I knew that needed to be important, if it was a real power law, needed to be some kind of explanation. Because remember, I told you that the exponent tell us about the process. Always, it's a fingerprint. If you understand that little number, you understand a lot about what causes what is going on. And I thought, and then I decided, you know what? I'm going to plot power laws of everything. So I studied to plot the power law of hash rate. I studied to plot in time. I never done that in time. I did it like one versus the other, but I never done the addresses as a power law. I never done hash rate as a power law in time. And all of them were power law. We were power laws of each other, power laws of time. And all of a sudden, I saw addresses as power law of time cube, and then price as addresses square. And basically goes like this. It goes, Bitcoiners grow with the cube of time. And then I say, what the heck? Why the cube of time? Where this cube of time is. And you can read in the article. But it goes, Bitcoiner to the cube, time to the cube. So they grow. So basically, if we double the time, we make 8 times more Bitcoiners. Okay, so it's that cool. We multiply the Bitcoiner as we double the time by 8 times. Okay, and then so it goes up with the cube of time, the number of Bitcoiners, and then every time we double the number of Bitcoiner, the price goes up with the square of that. And that is a well-known theoretical result that really is exciting, because we have also the theory. This is how you do science. You discover something empirically by looking at the data, and then there is a theory that says, yeah, it should be like this. So this guy worked the math of network. He say the value of a network, it can be the value in price, but also the value in utility, how useful a network is. As his result was the value of a network goes up with the square. It's a very simple exponential, by the way. It goes something like this, where it's more detail on paper, but the intuition is that it depends on how many connections. So if you have 100 users, and everybody, we always simplify by looking at the stream case, and then you can go and check, okay, what if there is not the stream case? What if there is this? What if one user is more connected with another user? But we always start with the simplest case. So the simplest case is, imagine if everybody in a network is connected with everybody else. It's unrealistic, but it's a simple calculation if you do it in that way. It gives you an idea. And so in that case, it will be the number of users times the number of connections. So each person is connected with everybody else beside you. So it will be n connections. So if I have an n people, n nodes, n users, everybody's connect as n connections. So it will be n squared. It's that simple. N times n minus 1, that is n squared minus n. But as you make n big, n squared is much bigger than n. So it's going to be roughly n squared. See, it's very simple argument, but you can also go back and do a simulation, doing more precise calculation, and show that it's the same result. This kind of calculation, by the way, were called back of the envelope calculation. And Fermi, again, my countryman, he was a genius with this calculation. And they are usually right. If you do it correctly. And so it basically goes like this: Bitcoiners times square, and then price Bitcoiners square. And now you can see, if I have time to the cube, I take the square of it with the powers, you multiply them. So 2 times 3, 6. You see how beautiful it is? So basically, the price depends only on 2 things: how many Bitcoiners we have, and the fact that we are dealing with a network, and the network multiply the effects of users. So instead of being linear, it's super linear. So it's the more of us, the merrier. It's like you bring it 2 friends, you get 4 times the value. You bring 3 friends, you get 9 times the value. Super fucking cool. I don't know how to say it. It's like, wow, this is beautiful. This is amazing. And then it turns out that the power law of hash rate is price to the square root of hash rate. And I have a theory why that happens, and you can read it in the article. It's something that I need to do more carefully, and I want to understand it better, but I think I have like one of these back of the envelope arguments. But later we can explore it. I want to create really like a science of Bitcoin. I even made a Reddit because we were so crappy with me. I don't know why. So I created a new Reddit I call the Science of Bitcoin. So actually, if you want to join, you can look it up. Again, I can put a link, and we can create a science of Bitcoin. So fuck them. We are going to study, and we are scientists. We are all of you scientists. That is the beautiful thing of science. You can be a scientist yourself. You don't have to trust me. This is not difficult thing, guys. It's simple stuff. And science is physics is the simplest. Is the simplest science because we like simplicity. This is one of the simplest possible things. It's not quantum mechanics. It's not gauge. It's simple stuff. Like you can see, if somebody takes the time and tries to understand, it's simple. Even British Older can. I wish British Odler was here because he makes fun and say, "Oh, I will. If this happens, like something impossible, I will understand the power law first." No. Oh, lasagna ingredient. Oh, by the way, guys, thank you so much, Campi, that I will get some lasagna ingredient. In fact, from next week, I order like an apron that says Bitcoin is the secret ingredient. And we are going to have a show called Bitcoin and Giovanni's Authentic Italian Cuisine. So I'm going to have once a week, I'm going to show you how to make real authentic Italian food. And we also talk about Bitcoin, okay? And so join us. I will put some, it will be on YouTube, but look at the times in my hacks. And it will be like, we will do a regular times. Every time, 1 week, we start with lasagna because Campi gave me, I'm going to make you the best lasagna that you ever had because you don't know how to make lasagna in America. You have no clue. And so you will find my recipe and you will say, wow, this is the best lasagna I ever had in my life. And I will teach you how to make it. So, and we talk about Bitcoin. We can talk about Bitcoin while I'm cooking. And so join us in this show. It will be on this channel. So thank you very much, Campi. I will get the ingredients for the lasagna. And I will mention you that you were so generous. Thank you so much. That is so generous. And so, yeah, this is it, and do you have any questions? Do you have any questions about this thing? Yeah. So do it and plot it and then post it. After this, I'm going to have a post say, this is a competition for the best. And then, if everybody's doing something, probably I can do it just randomly and they want to give you the indicators. I want to show you the indicators. Let me share the screen so you can see the indicators. Okay, let's see if I can find it. Okay, here. Indicators. Okay, do you see these guys? I think so. Yeah. So we made these indicators. These are on TradingView. So, sorry, I'm losing a little bit my voice. And we can take other 5 minutes because we are going since 2 hours and 30 minutes. We can have let's do this. Let's meet soon, and I will give you. This will be just a preview, and then we can go through the details of this soon. Okay, and you get these by joining our community in Discord. So you get Discord, and again, you can criticize me. I'm just trying to basically make this my job so I can fully work full time in this and help the community. So I don't do other stuff, get a job in Wall Street or whatever, work for you guys, and I don't want anything. I'm doing a very Spartan life. If I can pay my bills, very, very simple life. I'm all happy. And my son, because he's also quitting his job and he's helping me with his videos and so on. So it's $5, it's like stupid, almost stupid. Like people even criticize me. Why you're selling yourself so low? Because it's not about making money. I'm trying to be like think about a journalist or an artist that wants to be independent and is asking the community to support him. Is all. But we give these for one. The first one is $5, the other one $5, so $10 for both. And then you get to the Discord, and everything in Discord is free. The classes are free. So I'm spending hours and hours, professional, 30 years experience. I could charge hundreds of dollars, if not thousands, work with few people, privileged one, and then doing this for the community. So I don't know the people that criticize me do, but I will give you the link. I gave you the link. Patreon, join me in Patreon. Come be part of our family. But then, we have very clever people. They modify these. They make it better. They add other things. It's so crazy cool. But basically, and let me, because I'm losing a little bit my voice, give you just an introduction, and then let's meet in a couple of days and come look for an announcement in my X, and then we just talk about indicators. And it's basically, I made like what I call an adaptive indicator. Is basically like it's a little bit trying to give a little bit more value to the recent data. And so the result of that is still a power law. So let me close these so you can see better. But you see how, for example, you can find area of resistance or support. You see, look at this. We found the bottom here, and then the purple line was hugging pretty nicely that for many weeks. So it's a good way of saying, okay, we are here, we are having support, and maybe if we are, it never really breaks this one because that is a crazy barrier. I think has to do with miners. It's the miner capitulation line that we never break because otherwise the miners don't make money. But again, it's not something that if we treat Bitcoin as a science, we want to explore. We can maybe find out what exactly happens here, why we have this thing. But you see, look at this. It went to this other line, and then it stayed there for a long time. And now look, there is a dip. So we can use, and we are trying to work on these, we can put indicators where we get an alert if you go down one of these trend lines, and then that will be a dip. That will be a nice time to buy if you're saving some money. And said, I see how it does it again here. It went down, stay a little bit there, here support. It's almost like it wants to go through these power laws, these local power laws, because they are giving a little bit more weight. Is why it's called adaptive. It's just another way of looking at things. We like to use several tools and combine these tools. And then you see, look at this. And now, for example, it looks like this trend, the blue line is the trend, and all these are deviations from the trend, like 10%, all based on standard deviation, like maybe a multiple of a standard deviation. Standard deviation is basically the average distance of these points from the trend. And so, this blue line that is the trend, it looks almost like it's a resistance right now. It's not ready to cross. And maybe when it will be time to cross is when we start the bull market, the real bull market. And plus, below here, we have these. So another thing, and again, we can meet another time. I show you more. In fact, we can use of it. I think you can even do circular plots in that Demon application, and they can show you how I derived this chart. I put basically, I didn't get this because anytime somebody contributes something, I am the first one to sing their praises. This is a rational root came up with this idea to. It's something that again we do in science. Like I didn't invent a log plot. He didn't invent this plot, but whoever did it first for Bitcoin, he should be recognized. And I recognize him, rational root, great guy. He's another data analyst. And so he was able to put the data in a circular path. And here I'm transforming that circular path in a sine wave, so you can actually see it. And then I flip the sine wave, so the negative part of the sine wave became positive. So it's easier to see. But you see how these bumps, and so the bump became smaller and smaller because basically they are proportional to the price. As the price was smaller, you see how the price goes up in time because these are like a spiral. It's actually a spiral plot. I don't know if you ever saw this spiral plot that they make. And these two graphs, these two lines, one is what we call the full model. The full model is the yellow line. That is basically this guy here. It's the white one. You see, the white one is an attempt to combine all this knowledge, the knowledge of a cycle, the knowledge of the bottoms, and we try to synchronize it, but also the overall power law pattern to synchronize these bumps with the bubble. And it works very well. Look at this. Look at this. These are the first bubble that is all the way there, this one, this was not caused by the halving. The halvings are the triangle. So we don't model this one. We don't know what caused this. Again, it needs to be studied if you're interested in Bitcoin. but because it's not due to the halvings, we don't model it. But this one we do. And you see how it kind of cut the top, and then you can go down, and we have this thing we basically like a clock. This will be 12 o'clock, where we have a top, and you see it does a very, very, very good job. So we have different ways. You have cycles, and so the yellow one is basically the white line, what we call the full model, and the red one is the middle line. So it's a way of identify the different part of. It takes a little while. We give like training on Monday how to understand all these. We can meet soon on YouTube too and make like a little video about that. And then like this. Then these are 3 o'clock. So this is 12 o'clock. But this 0. This is when you have a top. Then when you think about if this is a sine wave, when the sine becomes negative, but remember I flip it, so it becomes positive. This cusp, is that the right term in English? The cusp, it's the bottom, and I color it in this way: red, green, and then many people sometimes are confused by these. They say, "Oh, does it mean this is a top?" No, it's not a top. It's another important place in the cycle that we call transition from there to bull. It's basically if this was negative, it will be the bottom negative part of the wave when we basically transition and we leave the bear market behind and we start to the bull. We start to be very bullish. And then, but it's not yet. It's almost like I can also think about season. This is, maybe this is winter. This is, autumn. No, okay. This is winter. This is springtime. This is summer. Okay, and this is the end of the summer. And so these are season or times, right? So we call it 0, 3 o'clock, 6 o'clock. This is when we go in transition. And then this is when the full bull, when the real crazy bull starts, so it is 9 o'clock, and then 12, and it repeats. And again, look how regular it is. Bottom here is at the bottom. Yes, these are the cycle before. Is the transition. You can see it. It doesn't look anything special happens, but if the market is getting ready to before the halving, it gets ready to start the bull market. And then this when it goes crazy and everything goes frenzy. Now we had a double top here, but again, because it's more complicated. It's not just like, yes, it's incredible that it's this regular, but it does also some weird things. Here we had a double top. We didn't have a double top before, and so it kind of went up before it should have. But you can also look at these red lines. By the time the price goes to the red line, you can get a little bit, you can take some profits and hope to buy back. It depends on your style. It depends what you want to do. If you want to, to ever sell your Bitcoin, more power to you. But stop buying, save the money, and buy back when we go down to the bottom. It depends on what you want to do. If you want to sell 50%, sell 50%. I will probably be more on the aggressive side of things, but you don't have to do what I do. Do whatever you feel is good. But the entire idea is to give you tools to do whatever you think is good, what you think is right. And also, we created a community so we can help each other. We can support each other. We can share ideas. There is some guy that in the group that is an expert on options. He told us, guys, don't sell because you will have consequences for the taxes. Instead, buy some options. So he's creating a group. We have a channel where he's helping us to understand and learn. So we can learn about options, and you can do options instead and gain while Bitcoin is going down. Maybe you can multiply. The goal is only one. We want more and more Bitcoin, right? So if this help us multiply Bitcoin, I calculated, I did some crazy stuff. Don't take it seriously. It's almost like kind of an extreme case scenario. Just to give you a feeling that if you were like a magician, and not even I can do this, just an extreme case, but just give you a range, right? If one gamed everything perfectly, that again, I don't want people misunderstand because some people would use this against me, but you understand what I mean, right? I'm trying to extreme case scenario. One sells at the top, one buys at the top, bottom. You even short that probably you should not do, but something crazy. Like I wanted to see what if you squeeze this lemon to the possible craziness. In theory, you could use leverage, but don't use leverage. Maybe use like $100 and put a little leverage there. Be very careful, but be flexible. Be like a martial artist of Bitcoin, come up with all different possible strategies that are sensible and don't do anything degen. You could do 320 pair, times in 10 years from now. If you don't do anything, it's 20 times. It's going to be 1 million. Don't do anything, just order 20 times as amazing. If you do stuff and use the knowledge that is here, look at this, bottom, but also the blue line. It's more than one thing, converging signals. You don't want to rely only on one thing, but a bunch of things. And then you find the bottom. Buy, sell your, sell your chairs. How many chairs do you have? Two, one more, you have too many chairs. Sell one, buy Bitcoin when we arrive there. And we will give signals, we will let everybody know and so on. In particular in our Discord community. And because that is the serious group, there are no trolls, we help each other. We're trying to get more and more people in the Discord channel. And then, you could make 320,000 3 times. It's crazy. Now, probably you're not going to get, make probably is realistic 30 times, 40 times, you can double what you will do if you just sit on it. Because, there is virtue in just holding, but if you can become a martial artist of Bitcoin, why not? Do it in a very careful, very aware approach, but you can do it. There is so much alpha, and Bitcoin is so regular and is predictable, and it will continue to be predictable because when you will see the video, we will explain it. This is physics. It's one of a few times when physicists feel very confident in making prediction if you have something that is called scale invariant, because it's been 8 orders of magnitude like that. You have this mountain, this Godzilla that grew in a very precise fashion. Do you think it's going to change to go to the next level, 10, next 10? 10 is nothing because it went from 8 orders, it went 10 times, 8 times, it changed by orders of 10. He did it 8 times in the same fashion. You think it's going to change? If you were close to be, more than gold, more than all the money on earth, then yes, it needs to slow down at that point. But we are very far from that. We are not even reach gold. So, and by the time we're 1 million, it will reach gold. So there is no obstacle. So when I do prediction, I like to stay within something that is reasonable. So next 10 years, I feel super confident based on science and based on scale invariance. When they say, oh, you cannot use it to make prediction, they don't know what they're talking about. They don't know physics. Yes, physics, if physics is right, and this is physics, is predictable because this is what scale invariant systems do. You look at the growth of an elephant, you look at how much it grew in 5 years, you can extrapolate it for the next, because this physics is not financial stuff. This is physics. And so you can make the prediction. If you say no, then this is not true, and there is something that all this is due to chance and who knows, and I think it's stupid. Or if it is true, then yes, it's predictable. How weird, strange, and let the people let them think that we know different, right? The martial artists of Bitcoin will know differently, and we act differently, and we will benefit from it. Let them think whatever they want. And here I'm trying. I'm extending the line, to see what is happening. Unfortunately, on TradingView, we cannot get more than 500 days. But I'm trying also to extend these. I will make it better. Just a first attempt, but you can see also how the spiral is extending in time. It will look better, and I'm working on it. But it's always a work in progress. We are trying to improve, and give more information as much as we can. But it's so beautiful, it's so rewarding and hopefully useful, so you can use it for your own advantage. Okay, so I'm going to stop because it talks so long, and also I'm getting a little tired. But thank you so much to follow, and I can take maybe one or two questions if you have it, and then we will stop. And please come to the Discord channel, okay? I can give one more time a link. Just sign up on Scale Invariance, support our team, and hopefully you benefit from it. And it's $5. If you don't like it and think it's stupid, you can leave, right? Nobody's forcing you to stay. But stay, because it's just the beginning. We are going to have so much more, and we are going to be productive. And for me, it's a passion. I love to interact with you. We have the book club. We have everything. Okay. Cosine function. Why will it change? Why will it be different? If I plot it as it's really neither cosine or sine. It's just like you adjust the phase of this sinusoidal in such a way that it's synchronized with the first bubble. It's kind of a trick. Say, okay, this is when it started, and then all the other bubbles are synchronized by themselves. The y-line is this full model that contains three components. It contains the power law. It contains sine waves that is supposed to follow the bubbles, basically. It's a way of modeling the bubble. And it forces the value to be 50% below the trend, because usually this is where the price is, most of the time during the bear market. Like here, it didn't do very much with it, but in the previous cycle, it was, you see how, well, here, for example, it was really following very well the white line. It's just one more way of representing the price and just giving you kind of a general direction of where the price is when we are in the bear market. You see how well it followed the general direction of this power law, right? And so here too, it gives kind of a R bottom that even during COVID, this was COVID. Look at this. COVID, here was something happened, who knows what, right? Where the price was a little bit more happy than it should be, because we reached the bottom and started to get all excited. Who knows? And, maybe there was something going on in the market, and then people got tempered by COVID. But even during COVID, it just wicked below there, and then boom, almost like a bouncing ball, it bounced from that. So it represents some kind of a hard bottom that it seems we never go below. So it's very useful. And then it continued to go up, and it never go too much beyond the orange line. And then it can go up. Here it went much higher than that. But it's again kind of a point where you say, well, if you are above this red line, we are within, maybe at most few weeks from the top, and so you can do DCA, right? Don't sell everything at once. There's some DCA, start to sell when you come closer and closer to that orange line. And then this here, look at this, how nice we caught to the bottom here. I even called it. I put it on I was not very active on X. I was more active on Facebook, and they call it. They say we reached. Everybody was screaming, "Oh, we're going back down to $5,000." Ridiculous stuff. And they say no, because Bitcoin never does that. It stay there. We reach that bottom. I called it. I made a post, and very few people even thought, believed me, because everybody was talking about going to 5 because FTX and all stuff. Bitcoin doesn't care. It reaches that bottom and it doesn't go, and then in fact it went up. So we are trying to add more and more information, but at the same time, we want to make it as simple as possible, as clean as possible, as elegant as possible. So you get all the information you need to get, but not confusing. And so you can actually use it, for your own benefit. Okay. If you're okay with all these, I'm going to stop. And I really thank you for all the support and being patient and following this, and hopefully this is useful. So, and come to a Discord channel, so you're part of our tribe. Okay. Thank you so much, guys. I give you a big Italian hug to everybody. Yeah, thank you, guys. You pay me back by, teaching me all this stuff that I never would have thought before. Thank you. Bye, guys. Bye.